Alright, practice problem 7.6 just says arrange the atoms of neon, sodium, phosphorus, argon, and potassium in order of increasing first ionization energy. Okay, so we're looking for increasing, so the ones with the highest ionization energy are going to be the least likely to want to give up an electron. Okay, so let's look at what we have here. So we have sodium and potassium, we have neon and argon, and then we have phosphorus. So why don't we try to start with the ones that are going to least likely want to give up an electron. And that's going to be our group 8A, right? Because these are noble gases, they don't really want to give up electrons. Well, how do we know which one has a greater ionization energy, neon or argon? Well, argon is in the n equals 3 shell, whereas neon is in the n equals 2 shell. And so the electrons farther out are going to be more likely to be given away versus the ones held closer in. And so neon is going to have the highest ionization energy. Argon would be the second highest. Okay, then we have phosphorus, sodium, and potassium. Well, if we look at sodium and potassium, it's kind of the same rule as the group 8A, except these are more likely to give them up. They're very happy to, and in that same way. Okay, so potassium is in the n equals 4, where sodium is in the n equals 3. And so potassium is more likely to give up its electron before sodium because it's farther out. So we have potassium, and then we have sodium. Phosphorus is in the middle, okay, and it's going to have an ionization energy somewhere in between both sets, and so it's in the middle.